Hello, and welcome to the continuation of our six-part series conversations where we look into the impact of technology engineering in a post-COVID-19 new normal. My name is Carlos Gonzalez, Special Projects Manager at Mechanical Engineering Magazine and ASME.org. Today, our focus is on manufacturing smarter after the pandemic. Digital manufacturing technologies from automation and IoT-driven data analysis need to be flexible for production networks, which include 3D printing, CNC machining, digital twins, IoT, etc. They have shown their value during the COVID-19 outbreak and made a case for a greater industry adoption post the pandemic. In this conversation, we'll talk with technologists whose job is to make manufacturing smarter into the future. We'll also examine how manufacturing will change post-COVID-19. For today's conversation, I'm pleased to welcome three guests who will show us what the path forward will be once the pandemic is over. John Wilczynski is the Executive Director of America Makes. He was appointed to the Executive Director in June 2019. Prior to this role, John was the Technology Director responsible for the facilitation of the National Additive Manufacturing and 3D Printing Roadmap and the program management of the America Makes project portfolio. John graduated from Pennsylvania State University with a bachelor's degree in mechanical engineering technology and has worked in a wide variety of manufacturing positions. Rob Bador is the Vice President and General Manager of the Americas at Protolabs. Protolabs is the leading online technology-enabled quick-turn manufacturer of custom parts for prototyping and low-volume production. Bador has held roles as Chief Technology Officer and the Director of Business Development during his time as Protolabs, as well as his leadership roles as Honeywell and McKinsey & Company. He holds a bachelor's, a master's, and a PhD degrees in engineering and computer science. Dan Schoolin is the General Manager of Industrial Metrology at Renishaw. Dan helps companies increase production throughput, maximizes flexibility, and ensures optimal part quality in precision metal manufacturing using both CNC and additive technologies. Dan holds degrees in electronics technology, industrial manufacturing, and marketing, and has over 35 years of practical experience with manufacturing, process evaluation, design, and automated process control. Before we begin, I want to thank our supporters. ComSol Multiphysics, a simulation platform for engineering design, part manufacturing, and scientific research. Eccentric Mold and Engineering, a trusted supplier for time-critical injection molding services. Renishaw, one of the world's leading engineering and scientific technology companies with expertise in precision measurement and healthcare. And Protolabs, a manufacturer of custom prototypes and on-demand production parts specializing in mold injection, additive manufacturing, and CNC machining. For our audience, if there are any Q&A questions during our conversation, please enter them and we will answer them after the conversation. Gentlemen, let's get started. Rob, I want to start with you. During this time, Protolabs has been deemed an essential service and has been involved in several medical projects in response to COVID-19. Which ones have stood out to you and how did you address the unique challenges of manufacturing during this time?
Thank you, Carlos. So you mentioned that we worked on several COVID-19 related projects. In fact, we've worked on hundreds of COVID-19 related products over the last 3 months as a result of the pandemic. And I'll highlight a few. You know, at Protolabs, we're a digital manufacturer, meaning that we've introduced software automation into the physical manufacturing process, from kind of the quote through to the production and shipping. And that allows us to make parts very quickly, right? So we could respond within a day or a few days to these needs across our different services in molding, CNC machining, 3D printing, and sheet metal fabrication. And we really saw a lot in injection molding of this kind of demand because the quantities that customers needed were in the millions. And it came upon them suddenly. So a few I'll highlight is, one was for the University of Minnesota, here locally in the Twin Cities, where they were making a respirator that was lower cost and meant to be scalable. So that was a new respirator design, and we helped them with a number of custom parts on that. We also worked on face shields, protective face shields, with a number of companies. Zverse was one that has publicly stated they're targeting 20 million. Of those products to help with protection against the spread of COVID-19. And so we've made millions of parts for them tied to those. Another was Neuromodex Molecular Systems, that make COVID-19 test kits, and we made a number of those. So really a range of products that we made tied to protecting against or helping fight against the virus of COVID-19 in recent months.
And Dan, similar question. How has Renishaw responded to the COVID-19 pandemic, and what projects has your company been involved with?
Well, first off, Renishaw as a company manufactures industrial metrology and 3D printing systems. So I'll answer this question in two phases. One is in our own manufacturing, and then what we've done to help our customers. So in our own manufacturing, Renishaw, because of our focus on highly automated, flexible manufacturing, we responded to a UK ventilator challenge and converted in a matter of days a chunk of our production, about 40% of our production, over to ventilator production, and specializing in CNC parts as part of the UK ventilator challenge. And so that enabled us to help as a group of companies and countries to provide ventilators at a peak demand time. But with our customers, we have a number of medical companies, many under NDA, so I won't mention them by name, but where we have helped them remotely increase their production without having more manpower required. So automating setups, automating in-process control so that checks and balances to keep the processes producing parts that are within tolerances are done with less manpower. In many cases, we help companies achieve ratios of 8 machines to 1 operator. So reducing the requirement for extra manpower coming into the factories. So those are a couple of ways that we've helped out. We've been involved in supporting the needs during this pandemic.
That's great. And John, I want to introduce America Makes. For those that are unfamiliar, America Makes unites several different industries and organizations to promote manufacturing innovation. But could you give us some background on America Makes and how you guys have responded to the pandemic?
Certainly, appreciate the opportunity, Carlos and ASME. So the simple goal of America Makes is to accelerate the adoption of additive manufacturing to help advance U.S. manufacturing competitiveness, and security. I think it's something that we're seeing realized firsthand with everything that's going on with the COVID-19 crisis, where we are positioned today and where we need to be. So at the Institute, we're really focused on 3 major things relative to additive, and it is convening the community, bringing them together around challenges, coordinating their response, so making sure we're all collectively working on the right things to move the industry forward as quickly as possible while taking into consideration all the necessary concerns around qualification, certification, et cetera, making sure we're doing the right thing. And then finally, catalyzing industry and actually taking action. So we, America Makes, are part of a network of institutes across the United States. It's called Manufacturing USA, and there are now 15 different institutes that make up that network. A number of them are funded through the Department of Defense, Department of Energy, and Department of Commerce. We happen to be a Department of Defense institute, and we are the first institute that was established back in 2012. So we're in our 8th year of operation, working on that overall mission of convening, coordinating, and catalyzing the additive manufacturing industry.
So my next question is for both Rob and Dan. You guys both work in manufacturing sites in different parts of the country. What has been the most significant impact to your workforces, and how have you guys responded? So Rob, why don't we start with you?
Sure, thank you. Yeah, so I think we were deemed an essential manufacturer. We've been working throughout this. Our job was to respond to volatility in demand and the needs of our customers. We did that both with COVID-19 related products that suddenly came, the need arose. We also did it with other customers who had really big volatility, what they had been forecasting for products that we're going to sell in the first and second quarter of this year. And what really happened were vastly different, right? And that sudden shock caused them to, have need for our help in many cases. So that, of course, meant that there was a big demand fluctuation for our business as well. And we're really set up to be, very versatile and flexible. And I think at this time, flexibility was really the watchword. But the pressure that put upon us was we needed to adjust our labor models pretty dramatically with changing mix and volatility that would change. Things were changing, as you guys remember, right, on a daily basis in many cases as demand was changing and the world was learning day to day. And so we had to reallocate resources. We had to really double down on a lot of those best practices that we've used before around, cross-training our employees, developing alternative working models, new shifts. At the same time, of course, we had to move like 700 people from the office to their homes, right? And so managing, that labor transition while making sure that everyone could be productive and effective. Those were some of the strategies that we used during this time.
And Dan?
Yeah, along the same lines, first off, we have a number of different operations in manufacturing. Our CNC operations, fortunately, because of the use of automation and process metrology, were by and large unaffected. The demand for the products was down because a lot of the larger customers in the world had shut down and were not receiving parts, but our ability to maintain those operations with minimal staff was unaffected. The biggest area where we were affected was in assembly operations, where we had to shut down for a couple of weeks and move things in order to make sure that we had proper isolation between people. And interesting, in our assembly operations in India, they had a complete travel ban. We actually had employees sleeping in the plant in order to maintain operations, and that was willingly. We didn't force that, but that was we appreciate the dedication of our employees. One of the things that I see though with our customers that we support, and in the U.S. alone, Renishaw has about 140,000 companies using our products. This pandemic has really driven home the need to automate and the need to have flexible, adaptable machining operations, which I'm sure Robert, Protolabs specialize in that. But all companies, even volume manufacturers such as large automotive manufacturers and medical, really see the need now to have processes that are adaptable, flexible, and that can be ramped up and down at a moment's notice. And that's really where we try to help people out. So.
And John, your organization being connected to so many different companies and institutions, how have they responded to COVID-19? And I'm also thinking about perhaps some of the organizations that have relied more on legacy equipment, not non-connected, non-IoT equipment. How have they handled this sort of pandemic, and what have they done to overcome those hurdles?
Yeah, I think Dan kind of really started to scratch the surface of what we're seeing here. The need for systems that are agile and able to respond and transition quickly. Obviously, we're seeing that right now as it relates to reacting to a crisis, but I think it's really highlighting the future opportunity of where we need to be positioning ourselves as a country to make sure that we're able to shift as production and needs vary, whatever the situation, whether it's a crisis or just varying in demand. One thing, and really the way we got started in this was through interacting with a number of our members. So we're a member driven organization. We have a couple hundred plus different members as part of our consortium. And when we first started to talk to them early in March, as all of this was getting crazy for all of us, we reached out and started to ask what they were doing, how they were positioning their organizations to respond. That's really what got us involved in this in the first place. Is there was so many people who were trying to help in some way, but weren't exactly sure how to get involved. That really led us down the path that we went down, and some of the work that we did with the federal agencies to try to provide some coordination. But there's countless cases of member organizations and non-members, obviously, who have, done everything from complete retooling. And there's a number of, very specific instances with everyone from small manufacturers to big OEMs that have switched over lines, used, and I think we've seen additive really shine here, and fit into a number of different roles within this transition, whether it be to rapidly prototype, and we saw that time and time again. We didn't know what we needed right in the beginning, so we started to print a bunch of things. In some cases, we realize, printing is not the most cost-effective solution. We can use that to rapidly prototype and then put out tooling for injection molding. So we saw it play a role there where it was both, filling the role of a immediate bridge to production, a tool to rapidly iterate on a new design that could fit into the manufacturing settings. And they weren't optimized, but they were filling a need. So we started to see that transition. Then as time went on, we started to see how, we're using the technology to set up and rapidly transition entire tool sets over to, ultimately enable conventional manufacturing. But we were able to do it in a time frame, and there's, a number of instances out there with different manufacturers who have done that. Some of the major print OEMs have done that. A number of the big, manufacturers we've seen in the news, like the Boeings and UTCs, and that list goes on, and it's fantastic. I think that's been the most impactful thing for us is as a industry is to show that additive, where it really fits into the future supply chain and where it has the potential to make an impact. It's doing it right now for COVID, but it has tremendous opportunity to do it long term for many industries.
So this is a good point to take a break and do a polling question. How much does flexible production capability factor into your evaluation criteria for your supply chain partners? Is it extremely favorable, somewhat favorable, neutral, not considered in the evaluation? For our audience, your polling question should be popping up right now. Please answer that. And while we're answering that, Rob, you talked about before about the labor structure. Have you relied on any new technologies in response to the adjusted labor structure? Have you gone more digital in your design process or in your manufacturing planning to compensate for the fact that you don't have your labor structure present in the facility?
Yeah, that's a great question. In terms of, I think one of the key lessons that we learned throughout this is that automation, and digitalization, when done correctly, really lead to flexibility, and it's that flexibility that was really important, so that the digital and the human, right, parts of our manufacturing process could really work together synergistically to be able to adapt to these changing needs and provide us with the flexibility that we needed to deliver. And so I'll give you an example of that. Part of what we've done pretty uniquely is automate the upfront engineering work that's necessary for making fixturing or tooling, right? And by introducing software and automation into that part of the kind of the front end of the manufacturing process. And we've done that both in traditional manufacturing processes like injection molding and machining and sheet metal fabrication, where we do it in an unconventional way, and through 3D printing, which is of course part of our business as well. And that's allowed us to help meet urgent demand needs because we could make that tooling in a day or a few days, right? So then as customers have had those shifting needs, we've been able to meet those needs quickly and responsively. And that's allowed us to then, complement the needs of the workforce, right? And how the workforce could fit in there. And we could shift that workforce as the demand changed.
And Dan, and prior to this call, you and I talked about the skilled labor force and how the skilled labor force was already suffering before the pandemic and has probably taken another hit after the pandemic. So what does the future of the skilled labor force look like, and how can we probably maybe introduce some resiliency into probably what might be a depleted skilled labor force since?
Yeah. So, I can use Renishaw's manufacturing as an example. What we do is we have a very strict design for manufacturing philosophy, so that we use proven techniques to build in quality in the process. And so what we recommend people do is actually start out with a footprint of a process that will work, and build metrology into that process so that you can reduce the reliance on secondary operations, secondary inspections, and things like that. So as we move forward, the nature of the skilled workforce is going to be an engineering supervisory role over systems that have self-control, rather than interjecting into the process themselves with manual intervention. And so we're working a lot with educators and universities to try to help. America Makes, for example, organizations that help tool for the future, to have the skill set developed in people to be able to manage these flexible, automated, self-controlled systems. And we think that that's where the future is going, and that's going to help the skilled workforce basically survive and thrive going forward.
John, the technology roadmap set out by America Makes identifies measurable and meaningful challenges to promote inquiry, knowledge sharing, technical advancements. Can you please describe the roadmap, the technologies involved, and how has COVID-19 challenged that roadmap? I'm assuming things might look a little different now.
Certainly. So our technology roadmap is something we've really worked on from day one. It's something that we work on and continue to iterate with our membership and with our government partners. We are a public-private partnership, so we're always seeking voices of industry, if you will, to provide inputs into the system. It ultimately is our guiding light, and it really is where we get ideas for our technical investment strategy. It's broken down into 5 major, what we call swim lanes or thrust areas, which are design, material, process, something we call value chain, and then AM genome. And there's a lot of complexity to it, so I won't spend too much time digging in on it, but it's really focused on taking a systems engineered approach to how do we mature a technology. So the roadmap has these focus areas, then it's decomposed into something we call critical technology elements. And then underneath each of those technology elements is pretty specific requirements. Those requirements are ultimately what we pull together to fund project work against. So that's kind of the overview of what we're doing. We have a very diverse series of requirements, and there's hundreds of different requirements out there. We're actively working on many of them. There's been a pretty significant portfolio funded against those activities to date, which is fantastic. And I think we've been able to make a lot of progress over the years that we've been working this. COVID-19 has, I wouldn't say it changed our focus, but it certainly, created a focal point of activity. We admittedly had not been, as well connected to the medical community as we are to some other communities. So, that's something that we've certainly been working through and been maturing very rapidly, like all of us have over the past few months, getting engaged in this world, and understanding the regulatory requirements. I mean, that's really where we've, I hope, provided a pretty significant value to the community, making sure people understand when and where and how they can get engaged. Ultimately, the roadmap is what we use to provide our focus. This has created a very specific opportunity to rally around applications. And I honestly think it's something that's been very powerful for us as an industry to really help people understand where additive can fit in. I talked about it a couple of minutes ago, but additive is not just about one thing. It is very diverse. There's many different processes, many different materials. In COVID, there's been a lot of use cases that we've seen that have been polymer based and things like that, which is fantastic. That doesn't mean that is what we need for the next crisis or for any specific industry need. And we're fortunate that we have very diverse process across additive manufacturing. So I think the biggest thing that has come out of this is really a ability to help us focus. And we've always struggled a little bit, if we want to be honest, with applying the research and development to the application space. This is really focusing us on the application space. So we as an institute are focused on applied research. So we're not in the basic research community, and we're not necessarily commercializing products. So we're trying to bring those two communities together. COVID has really created a focus on accelerating the adoption of the technology and moving towards commercialization, and really understanding how to disseminate all of that information. So, the two other folks on the phone are doing that every day. I mean, that is, I imagine, a big part of their world, that they're making product that are using the technology to actually make goods, which I think has been a fantastic and very powerful outcome as part of, all of the difficulty that COVID has had for us as a technology. It's really delivered against the need.
And just to dive into that a little deeper, could you identify what technologies are being pushed to the forefront? Because you're saying now we're talking about investing into applied research, things that are practical. Are companies leaning more towards additive alone, or is it also additive and simulation, additive and digital twins? Since being together is the problem, right? Because COVID-19 puts a proximity distance between employees. The digital landscape seems the only way we can work together now.
Absolutely, and that's somewhere where we sometimes stumble, as an organization, in focusing too much on one thing. I think the major advantage additive also has, and it's not necessarily that different than where we're really at with CNC, and the realities of that world is everything's digital there as well. We're not doing, hopefully, too much on pen and paper anymore. But it's really all of those different technologies coming together to enable a product. I mean, that's what's ultimately, it's not additive that was able to produce a component in 3 days. It was additive coupled with this rapid simulation that is possible. Honestly, rapid qualification, our desire to move towards in-process sensing and detection and all of those kind of things. It's ultimately what's enabling us to very rapidly not transition in technology, but rather rapidly retool or develop a component. It is ultimately what's going to make us agile and create an opportunity to, whether it's reshore or upskill the workforce or whatever it might be, it's just a piece of that overall thread of activity that needs to come together. It happens to be something people can understand because of how the product is actually manufactured. So it's where it all really comes together. But it couldn't be done without all those other supporting or enabling technologies.
Dan, I wanted to go back to what you had talked about, automation, and also the fact that you are a metrology expert. And maybe some of our audience may not understand what metrology means and how that gets applied to a system, but metrology can connect automation and IoT together to move forward. So how does that all relate? And could you kind of give our audience an understanding of what that means?
That's an area of passion for me. So really metrology is the science of measurement. And back in caveman times, if somebody was making a tool one-off, it really didn't matter what size and shape it was. If it fit your hand, it was fine. But as we started to mechanize and distribute manufacturing nationally and globally, it became important to have standards of traceability so that if a manufacturer in Atlanta, Georgia was producing a part that was going to be assembled with a component that was produced in China in Seattle, when they put those parts together, they actually fit and had good interoperability. So metrology has been a foundation of modern manufacturing since the beginning of advanced manufacturing. And it's critical for all operations, especially when you get into automated systems, because there are a lot of things that are done by humans that are overlooked. For example, a company may go in and look at a factory and say, well, all John is doing is taking the part off this machine and putting it on an inspection device and looking at the numbers. And so they put in a robot that moves the part from the machine over to the inspection device. And they forget the fact that John was listening to the machine. He talked to the guy that was running the machine, put his hand on it, felt for vibration. When he picked up the part, he felt whether there was any sharp edges on it, what the surface finish felt like, and whether it was hot or cold. So there are a lot of things that have to be measured that are overlooked when people move toward automation. And that's really where we come in with technologies, and also from a consultative standpoint to help people understand the transition from manual operations to automated operations, basing that on sound measurement principles that can be looked at globally. And that's where the connection is with simulation and, you know, the 3D modeling and digital twin. If you don't have a traceable foundation of the size, shape, and form of that workpiece, the model is irrelevant. It's very important that when you're looking at the model, that model actually represents physically what is going on inside that factory. So as we move toward this more automated world, the need for metrology, not at the end of the process, which is a grossly inefficient way to do manufacturing, which quite frankly a lot of companies do now, is they will produce parts, check them, and if they're good, they ship them. If they're not, well, then they absorb scrap or they do all kinds of rework. What we do in our own manufacturing, and we profess with customers, companies that are achieving high degrees of efficiency, is building that metrology, that measurement in each stage of the operation. Prior to even cutting or 3D printing the part, you apply metrology to the models, you do advanced testing. Then you setting up the equipment, you apply metrology to ensure the equipment capability, whether it be a printing machine or a metal cutting machine or a grinder. Then in process, taking measurements while it's still possible to take corrective action in a closed loop process control standpoint, so that these operations can control themselves, so that when the part comes off of the end of the line, whether it be printing or grinding or CNC machining, the part has known quality built into it, and you're not sorting through for good parts. It's built right into the process. This is becoming even more critical as we run more unattended operations and we look at operations that are distributed around the world, especially as we're now looking at reshoring. We're seeing a big move to moving manufacturing back in, or to each country, not just the US, but every country is looking at moving manufacturing back in. It's critical that the components that come from these different facilities have traceability, and that's built into the process. So you keep the cost down, you keep the amount of manpower that's required down, and that you have a successful, efficient operation.
And Rob, that kind of turns my attention to you. You know, if metrology is to help people to be more efficient pre and post manufacturing, how has Protolabs dealt with, let's say, iterations? You know, in this time, we don't want to iterate that much because we want to avoid interactions between customers to help not spread the virus or the pandemic. So everything has to be done pretty much perfectly on the first run. How has Protolabs answered that call?
Yeah, that's a great question. So I think we've taken a multifaceted approach there. First of all, I think it starts with the quote and the engagement with the customer at the time of quote. So you talked a little bit about the virtual realm and about digital twins, and you know that's something that's really core to us, and something that we've been doing for going on 20 years, right? We make actually a digital twin of every part as part of the quoting process, right? So we kind of virtually manufacture the part so that we know the steps in the process ahead of time. And we actually provide that back to the customer in an interactive 3D digital twin form online. Doesn't require any special software for them. That then gives them the insights around the design for manufacturability. And it also gives them a definitive price, not a budgetary quote. That's why we started doing it, but the benefits are also expanded because the customer then gets that DFM feedback and the design guidance to ensure that the part is going to work as designed before they order. So I think that's the first step, making sure that that contract is right, making sure that the customer understands how that part is going to function virtually before they even engage in the order process. Then once we started going, we've got to make sure that we're doing the kinds of closed loop measurement that Dan talked about, right? And we do that within each of our processes, and it's a little different for each process that we have across, making a mold versus 3D printing versus sheet metal fabrication or what have you. And then also ensuring that we've got that traceability, throughout the digital thread that we've built into our processes, which then minimizes the rework, because the point that Dan made around inspecting at the end and then finding that you have a problem and having to go back to the start to rework, that causes a lot of cost and inefficiency, but it also takes a lot of time. And our business is all about being fast, right, and being reliable. And so we've got to get it right the first time if we're going to be able to meet, one-day turns on custom parts, as we do hundreds of times, thousands of times a day. So that's really important for us to have built in throughout the process. And of course, we also have, quality inspectors, and we do the human aspect of it as well. But introducing that automation and digital thread throughout the whole process end to end, based on a contract that uses the digital twin with the customer, and so therefore they have great detail and really understand what they're going to get before they order. Those two coupled together have been kind of how we approach that problem.
And John, speaking of what the customer gets, and what product is delivered to them, we've seen some cracks in the manufacturing supply chain due to this pandemic. What are some of the lessons learned in the last few months because of the things that we've seen be affected by this into the supply chain by COVID-19, and how can we be more resilient in the future for that supply chain?
Absolutely. Yeah, I think a couple of different ways you could go about answering this. There's, very specific as it relates to management of crisis and preparation for crisis. I think we all realized we were not as well prepared as we would have liked to have been. That being said, I think there's a lot of opportunity to, as we think about what the next generation of the strategic national stockpile looks like, there are, through some of the different tools and technologies that we've talked about already, ways to be much better positioned moving forward. So, we've coined our overall response as the advanced manufacturing crisis production response. So how is the manufacturing community able to be positioned and resilient enough to respond to crisis? Obviously, that could be extended to becoming agile enough to, expand competitiveness, et cetera, et cetera. But if it's specific to the crisis, we realized we didn't necessarily have the digital data we needed to immediately fill the need of some of the shortages that existed. We can solve that. We know how to do that, at least in theory and in practice, honestly. Having a digital stockpile that exists that we can have, even to the point of having multiple processes qualified at some level for the most critical components, we can be better positioned so that when a conventional process isn't capable, even if it's for a short period of time, we're able to come in. I think that's, we saw additive play a major role in that. The most well-told story as it relates to COVID has been, around PPE. But the flexibility that additive ultimately enables is really where a lot of opportunity lies. we've talked a lot about onshoring over the past couple of months, and that's, as Dan pointed out, it's not necessarily the U.S. wanting to onshore or another country wanting to onshore. We need capability at some level local. We need to understand and be able to execute distributed manufacturing. We are fortunate in that additive manufacturing creates a tremendous amount of flexibility to be able to realize those capabilities. So I think, that's something we've learned. I think we're starting to see a lot of movement. We'll see how it all ultimately plays out as things happen. There's a number of different, bills introduced in Congress and different things like that are really looking to take some steps towards a kind of a digital stockpile. We've been calling it the digital seed bank, but the whole idea, whatever you call it, it's a model repository at some level that we can, if needed, break in case of emergency, go off and do this thing. However, I think there's a lot of opportunity to take our learnings here in this near-term crisis and think through what does that mean longer term across the country. And I think there's tremendous opportunity to do that. It ultimately can play out where we're able to use the technology to distribute manufacturing and enable supply chains and ultimately become more diverse and more resilient really across the United States.
And that brings me, to the final question for all of you. What does the rest of the year look like? Because we're still in this pandemic, right? We still don't have a solution. And we don't know what the fall may bring or the winter, and the vaccine probably won't come until next year. So manufacturing is still changing, and it's still adapting. It's still responding to this. So Dan, why don't we start with you? What are your top predictions for the remainder of the year, and how that's going to be a long-term effect for manufacturing going forward?
Well, we are seeing in our customer base a move toward flexible automated manufacturing so that companies can be resilient for this type of crisis that occurs, whether it be the continuation of the pandemic or anything else. I think this is driving the need for people to have the type of systems that can be self-maintained, can be started up and shut down very quickly. Wanted to tie in on a couple things that both John and Robert talked about. De-risking is very important for companies right now. And so, I've had the pleasure of working with companies that have received models from Protolabs. And actually, we've been able to take those models, take information about the CNC process that would be used later, and run it through simulations to determine what type of productivity we could get using that information. So it's very valuable having a good, accurate, digital model that has metrology associated with it. And then being able to take innovation, and if there's a changing need or some new design that needs to come up to meet the needs of a crisis, so like America Makes and John talking, I'll give you an example there. 3D printing has often been looked at as prototyping, but it doesn't stop there. Actually, 3D printers, in the case he was talking about, where you produce a few parts quickly on a new design, and then it goes into plastic injection molding, where you need high throughput, you can 3D print the molds with internal cooling channels so that you can produce 3D parts faster. So that enabling technology to rapidly prototype for an innovation also is an enabling technology for the higher volume application to produce parts more quickly and of higher quality. So this is the way, what I see going forward is companies are becoming smarter. They're trying to reduce the risk by incorporating these type of technologies. And as my dad used to say, measure twice and cut once. So doing the work up front.
Rob, same question. What are your top predictions for the remainder of the year?
Sure, thanks. I'm optimistic about the remainder of the year. I think that we've talked already about flexibility. I think there have been a lot of lessons learned by manufacturers during this time. I think we went through a very significant demand shock that probably tested kind of the core hypotheses and core tenets that a lot of manufacturers were working around. I've seen what I believe is tremendous response to that, where the manufacturing community has really been thoughtful about, how do we de-risk some of these things? How do we make our supply chain more flexible in this scenario, managing supply shortages, and seek alternative technologies and other suppliers, right, to help limit our. Starting to see greater flexibility built into supply chains as a result of this, and more of a drive for advanced manufacturing technologies, and we're helping a lot of our customers, to do that and be part of that solution for them. But also as I reflect on this, I think this has been really a terribly difficult time for the world and for the U.S. Between the pandemic, the strained international trade relations, and then the recent murder of George Floyd here in the Twin Cities, it reinforced to me that I think how people treat one another and what we can do to help one another is really what matters. And I'm proud, actually, of how the manufacturing sector has responded to this crisis. And at the same time, I'm sure we can do more. And so I invite us all to join in that endeavor.
Thank you. That's great. And John, final words. Your top predictions on how the world responds. What does America make stinks?
So I think honestly, Robert just kind of walked through, the scenarios we've seen play out. I think the response has been tremendous. I think if we learn anything from 2020 and the wild ride that it's been already, is crises are going to come and go. I don't think many were very well prepared for this. However, we know there's going to be more, and they'll be diverse. So we have got to make sure we're learning something for this. I think immediately, one of the things that we're seeing is that there is quite a bit of focus on preparation for what may or is likely to be, depending on who you talk to, a second wave, or at least we know there's going to be continued activity in COVID for the coming months as we await a vaccine, et cetera. We're seeing a much more structured response. We're seeing folks both prepare and resupply in a manner that I think will hopefully keep us better positioned. We've certainly learned a lot about how to work in this environment. I think we've all learned how to do this a lot more effectively. We've been able to build relationships, via electronic communication. So all of that has proved to be quite powerful and probably in some cases added, efficiency to our process. But I think it's going to, we're not going to forget about this. It's causing us to stay focused. And I think that the value in that is we're going to be better prepared. And we're learning a lot from this. And I think the other fantastic thing is everybody has been very willing to share their lessons learned. I mean, this has not been something where anyone is, overly worried about how it worked for me and not letting someone else know that, so that it remains this, competitive advantage. Obviously, everyone needs to stay in business, and that's certainly been challenging for a number of organizations. But, at our core, I think the manufacturing community has really stepped up and shown, if I figured it out, everyone is, people have been very open with us and sharing their stories to make sure the best we can help publicize those. So there's a number of, I'll say actions in work right now that we're working on for impact reports and lessons learned and those kind of things that is going to ultimately benefit everybody. And the key is going to be making sure we don't forget and we actually, take action on this so that we're better prepared.
Agreed. Well, gentlemen, thank you so much. This concludes our conversation for today. I want to thank our speakers again, Dan Skulin from Renishaw, Rob Bedore from Protolabs, and John Wazinski from America Makes. Also, special thanks to our supporters, ComSol Multiphysics and Zentric Mold and Engineering, Renishaw, and Protolabs for supporting today's conversation. Our next conversation in the series is next Tuesday on June 30th. It will focus on rebuilding the medical supply chain after COVID-19, and that will be moderated by our senior editor, John Kozowatz. Thank you everyone for tuning in, and I hope you enjoy our next conversation and have a great day.